Welcome to Inside Builder channel, large language model automators, Python experts, and my dear friends. Exploring the power of GPT4All inside Langchain. Testing with tools, agents, and chains. The intention of this presentation is going to be working with GPT4All in your local environment. That is the primary purpose of this. Even though you would have already seen a lot of videos where they show how to run this in local environment, this video will go one step above and it will start working with various ways of interfacing the GPT model with the class constructs in Langchain. That will be the primary objective of this presentation. So before I go really into the presentation, I just gave an overview. Let us go back to the browser. The GPT4All was has been released by Nomic AI, and you must have heard about it a lot. I am not going to go in detail about this. The point here is that we are going to primarily concentrate on how to get this work in our environment. Before we start, I really thank the Nomic team, Lucas Priusal, who uploaded the Nomic quantized model in Hugging Face. We'll be using the uploaded model, and Thomas Antony, who helped in creating Llama CPP Python library, which will be used by Langchain in order to interface the model that is GPT4All model with Langchain. So all these people have done a great job so that today we can actually start working with Python on Langchain. So a lot of work has gone in this. This is very important because at the end of the day, the step that these people have done, Nomic, Mr. Crusel, and Mr. Thomas, has actually led us to use the model more easily in our environment. We will, if you are thinking, okay, why test and what are the tests that is going to be done? Most important point is that large language model, as I was explaining, is kind of a controller, or it's more of a backbone when it comes to working with the various interfaces like your data stores, your files, your services. Future it is going to be like that. Having a large language model that is present locally and you can use it at your will is going to change how we interact with the world in near future. So I hope that you guys will really understand what is going on here, and also implement it in your own environment. The way this particular video is made is particular test, and the video is made is that I will be introducing the test that is done, and then I will be also sharing, as usual, the notebooks, as well as this time there will be a script also. In all the previous videos, I only shared the Collab notebooks. This time I had to move to a script, move the commands to a script, the Python script, which can be run in your local environment, and you can test it by yourself. The point of creating this is that then by running it in your local environment only, you can understand what is actually going on. Without that, it will be extremely tough for you to really to judge that, okay, how to use this technology. So that is the main intention of this. And I hope that you like these videos, and do leave a like and share it with others. Very important, guys. Please share this technology with others and subscribe to my channel so that further updates on Langchain and the big data related concepts will be shared here. With that said, let us go to the tests. Initially, I'll be working with a simple large LLM concept. So I will not have any kind of chains or anything. It will be a simple Langchain based LLM. I did not get any output when I was testing it in the Collab notebook. When I created an LLM chain class object, then I got an output. In case of Pandas data frame agent, it errored out. And in case of request chain also, it errored out. This is all in Collab notebook. Okay, I'm not talking about in script. In script, I have still kept this, but I will be showing it to you. I have commented it out. So, but I have anyway still coded it there, because in the future, when the things change, we will update it, right? And finally, LLM along with other tools and initialize agents. So when I started working with the tools like Google Serper API and initialized it as an agent, then it was able to actually get the output, and it was I was actually surprised by that. So you will be seeing this in action in a moment. The major challenge, what I understand from this various tests, is that how we tokenize the prompts and the data that is given to it. So that is where these two tests failed. So I have actually given the failed tests also here, because see, when you are only going to share everything that is success, you might actually think, okay, this is easy. But believe me, guys, it has to, a lot of research goes on into this. And I personally want you guys also to explore more, because once we start exploring, once you guys start exploring together, then we can learn a lot. So that is the main intention of sharing what is exactly going on also, so that it will be much more useful for you and the whole community. As I was telling, all these people have done a great job, and they have moved the community as a whole a step forward. I would say 100 step forward, but still. So with that said, let us go to the Collab notebook and start working on that. So going here, if you guys by any chance are coming to this video directly and you are not aware of Langchain or large language models, take a look at this playlist where I explain everything from the beginning for not only the Langchain library, but also on the large language models. You can get a good idea about that. And the repo where the code, the Jupyter notebook as well as the Python code is stored, will be shared to you in the video description. That is below in the YouTube video description. Take a look at that. You can get the code from there. And this is the repo that you will be working on. And finally, coming to the Collab notebook. This is the Collab notebook. You have to just use file and say upload notebook, and you have to give the GitHub repo link, and it will open this particular notebook. So note this point: when you are going to your regular environment, you need to install all this in your regular environment. Okay, ensure that you all these are important libraries, so ensure that you install it before you work on the regular environment. Coming to the first and foremost step, we get the quantized GPT4All LoRa model from Mr. Lucas's repo. His Hugging Face repo, the model has been uploaded. We will be pulling it, and once we pull it inside the Google Collab notebook, it will get populated in the content directory. So that will be the root directory. Once you do this once, you don't need to do it again. So this is a 4.2 GB model, so ensure that you have sufficient bandwidth, or else you will actually end up in trouble. So you will not get the model. So you understand what I'm trying to say. We are going to start working with a llama cpp class inside langchain.llm. So when you are going to install it, and if you already installed Langchain, better do a pip install upgrade Langchain. So here, when I'm doing here, you see that I'm doing pip install Langchain, but when you're doing, use a upgrade here. So use the upgrade option and then do the Langchain. What happens is it will pull the latest classes or latest code that has been written by the Langchain developers, and it will put it in your own environment. Or else this particular class will be erroring out. It will say that okay, Langchain does not have this class. So ensure that you properly install it. And I have just run it already, because I did not want you guys to waste your time. So I've already run it, and I'm using very simple prompt templates, and this is the important point. So I am initiating the model. So all you need to do is just pass this model path into llama cpp with capital C, and the model gets initialized. Behind this simple class initialization, lot of code actually goes on, which is not shown to us. So it has been completely abstracted. Langchain guys have done a great job. I want to leave a shout out here for them. And it's one of the it looks very simple, right? It looks extremely simple, that all you do is create a class. But in fact, it's not that simple. If you take a look at the various libraries involved and various code you need to execute to get this model in, it's not that easy. Because I was planning to create a much longer notebook, because I had to go multiple steps to get this model loaded into Langchain object. That is to create a large language model that can be operated by Langchain environment. But thanks to Llama CPP, we don't need to do it. So all I need to do is just run this single sentence. And after that, when I tried, after that, when I asked the question, which team, NFL team, won the Super Bowl in the year Justin Bieber was born, and I gave the question, it actually did not give any output. So it took a lot of time, and also ensure that it will take a lot of time, guys. The RAM also, it will take around 4 to 5 GB of RAM. So ensure that you have a good RAM in your machine also, because you are going to run all these things as a script. I'll be showing you the script also in a moment inside the command prompt. So I create a chain here, LLM chain, that is again a large language that's a Langchain class again. And when I ask this question, so the same question, I send it through this, and we get the answer. Okay, you see the answer here. So the answer is right. Actually, I checked it out also. I think the answer is right. But whether the answer is right or wrong, that is a secondary thing. The point here is that it is able to properly go through the question. It is also, rephrasing the question and responding to us back in the LLM chain. So this is one of the good things that I actually liked about, and I wanted to share with you guys also. And then starts the challenge. Okay, so I got this chain right. So I got greedy. So I wanted to get the pandas data frame immediately read, and I wanted to do lots of analysis. And I wanted to work with request chain also. But both of these things errored out. Okay, what I find so I'll be executing this. So I have not executed it earlier. I can execute it right now. So what happened was that it enters into the chain, and then it actually says that failed to tokenize. So what I understood is that the data that I'm pushing into the environment is actually huge. And when I'm initiating this large language model, right, I think I need to also understand what goes on internally, how much is the tokens, etc. I need to modify that. Okay, as of now, that particular study I have not done. So that could be the one of the mistakes that I have made. But still, this is what is the result. So we see that. And then I wanted to create request chain, and in case of request chain also, I started facing the same problem. So when I was sending the request chain, what it was happening is, again, so the request was going out. So I asked what are the 3 biggest states in India and its population. So I'm asking for a Google search using a request chain. I'm not using any of the APIs here. It's a request chain that is going to work, and I'm writing the net. I'm executing this, and I get the similar kind of an error, because I think that it is because of the token sizes or the context that we are providing. So it's still getting the data. You see the data is coming out. Probably I will have to zoom in a bit. So I hope that you guys are, sorry, I completely forgot about zooming in, but I hope it is still visible. So the point I was trying to make is that we can see that it is returning the data. However, because the LLM is unable to process it, it is erroring out. Okay, so we have to still work on this. But yeah, apart from all this quirks, the final point I was doing was I used the load tools and use the initialize agent. Okay, just a minute. I'll be updating the SERP API key here, and I'll be getting back to you. So I have already loaded this, and now I'm going to load the Serper, Google Serper. So this is actually Serper API key. You have to just put your API key here, and I'm initializing the agent. This is the regular process that we follow. And then I ask, okay, what is the weather in Delhi? And you see, it actually gives the reply back. The point that I wanted to make is, first and foremost, ensure that you give sufficient time. Don't be in a hurry. You have to test it out step by step. Okay. And also ensure that your system is up to date, not from the perspective of your software and all. You need to take care of the Python packages are up to date. Because most of the time, in case of Collab Notebook, a lot of packages are already installed in the Collab Notebook. And when you try it in your local environment, I'll be showing the script in a moment. Just a minute, let me show the script. So this is the script that will be, it's already shared with you guys. Before that, let us see what is happening here. The agent executor is still running. You saw that it's already almost 2 minutes. It is still running. But anyway, let us go and start explaining you the script. Script is nothing different, guys. I have just taken, you see, even the script is directly taken from the Collab Notebook only. I have not changed anything. The point here is that in my script, I have commented out the download, because when I am running, I have already run it once, so I don't need to get the model again. So I have commented it out. When you start, uncomment it and then start working. Okay. And I am going through the same process that I show in the Collab notebook. Only thing is, I have added additional print statements so that you will understand what is going on. So like the print statements that you see here, I have added it. And this is the first LLM where it is. Yeah. Just a minute. This is the template that is getting created, and reply. This is the first reply. So you see this. I have actually commented it out because it's not giving me any value. So when you run your script, you can uncomment it and do the script run and see what happens. Okay. And in this case, reply 2 is using the LLM chain. It gives the reply. You can see that I'll be showing it in a couple of minutes. And then I continue with this. Again, here I have passed the try except block, because the reason is that this particular the agent, when I tried to run it using the data that is provided, so this data, the space shortened CSV also is available inside the repo only. So you can find it out inside the repo. I think it is inside the one of the project folders. I will share that link also so that you guys can get it, or you can put your own CSVs. It doesn't matter there. You can just edit it and update your own CSV file that is available with you and try it out. But the challenge is that you understood, right? It will error out because it is unable to tokenize. And then I use the request chains, and that also I have again passed it. So here I initiate the net chain, and then I try accept it using the reply process. Why I'm using try accept? Because I am running a complete script. So if any of the replies fail, or if any of the prints fail, then I will just accept it and go to the next step, or else my script will stop. So that is why I used it. And also the script will require your Serper API key to be provided along with the command. When you are executing Python, the script name Python exploring underscore GPT4All.py. After that, you need to give the key, the Serper API key, because in that way I can share when I do it like this, I can share the code with you guys without thinking twice. And then I'm loading the tools, I'm initializing it, and this reply I'm also going to share it with you. I think it is done here, and we see the result here. And you can check it out that it is overcast by 41 degrees Celsius in Delhi right now. The point I wanted to make here is that the GPT4All actually, it works with 4 GB of RAM, and it is easily loadable. So we saw the script also. Now what I'm going to do is I will connect to my machine, and I will show it to you how to execute this. Okay, just give me a moment. I hope you guys are able to see the prompt here. I have already git cloned the entire library, entire repo here, and I am entering into the folder where my code is available. The code is available inside Langchain. Just a minute, it's in projects, Langchain. I think it is exploring GPT4All. The code is inside here. So if you do an ls now, you'll see that I already have the model here. You see this? So you should keep the model in this place only, gggt-model.bin. Once you execute it once, you will get the model directly also in this location only. And here also you see the space underscore shorten CSV that I shared it with you in a moment ago. It is already available there. Once you pull the repo, you will get it. And the document exploring underscore GPT4All.py. This is the Python script that we will be executing. So I will be just doing a cat command, and I will be showing it to you guys. Whatever I showed it to you in the GitHub repo, the same thing. I have just pulled it here. Okay, nothing different. What I'm going to do right now is I will not be able to show you my Serper API key, right? So what I'm going to do is I'm going to execute this, and I will get back to you. So you see that the script has started executing, and the Llama model has started loading, and all these things happened inside the Collab notebook also, but it was not visible to us because it was inside this cell. We couldn't actually see that. So now you are seeing it in a step-by-step process. And give it time, guys, because The laptop, the system that I'm connecting with is in the cloud instance, and I have given a 4 or 8 GB of RAM, I suppose. I don't exactly remember that. It's in between that, and it takes considerable amount of time, because the entire process goes through various kinds of loops. When it comes to large language models and getting coherent sentences out, it is not just neural networks. Actually, there is mathematics also involved. When the data is given by the large language model or the neural network, the words are again rechecked by a local algorithm, whether the particular word frequency is sufficiently matching with the regular coherent sentence. So there is a kind of a process that goes through in the backend. If you there is a separate you saw that the first reply we got it. You see the data here, reply from LLM chain, and the rest of the things I have actually skipped. So agent setting has been done. All these things I have skipped it. In this place, it is not running. Right now, it is directly jumping to the last step. Why I skipped it? Because I already showed you guys that it is erroring out. I did not want to spend again time, because each of this time, right? Each of this step, it will try to get the data for you, and each of these step it will error out. Instead of seeing the errors here in the script, I already showed it to you in the Collab Notebook. So you guys can still let it run. In the meantime, let us go to the browser, and in the browser, yeah, you can uncomment it and run it. Whenever you uncomment it, understand you have to uncomment it, remove the pass from here, and then run it. So run it one by one. I have given you all the things. You don't need to run everything by a single go. You will get frustrated. That it takes a lot of time. Why to do that? So you go step by step and understand, okay, what is going on, and you will understand very, very clearly that how this is working. Let us go back to the terminal once. Okay, still the executor is not completed. It takes almost 2 to 2.5 minutes. So it's a regular thing. Now let us go back to the PDF now, because I wanted to think for you guys also, and I wanted you guys also to think right now. Since you have the GPT model right at your command prompt, how are you going to use it, and what purposes you will be what purposes you can think of? First and foremost, what I thought of is to have a personal assistant. Just by using a Python script, the script is already available. You saw that, right? All you need to do is write a while loop so that it keeps on running. So you have to just ask it something. You have to wait a bit. Probably it's not as fast as whatever you are seeing from GPT-4 or GPT-5 or whatever model comes out. However, all those models have one big disadvantage. That is, it is outside your system. This particular model is inside your system, right at your control. It is connected with Langchain. You can do a lot of stuff with it using Python. You can log whatever you are asking for. You can try to work with various kinds of interfaces, various kinds of files. You can play with the token models, understand how the tokening is working. So as I always say at the end of my videos, practice, guys. And now this practice is going to be pretty interesting. It's not going to be boring. If you have done all the earlier practices, now it will become interesting. The point here is that as you practice, all the steps that I'm telling in my earlier presentations will be very useful in this particular time of discussion. Let us see whether it has done. Let me check it. Yeah, I think in my case it has done. I'm going to show it to you. So you see this, the output has been populated here, and you see what is the actual number of tokens, the number of runs it has gone through. You can get a lot of information, and it says, okay, it is saying Delhi is at 20 degrees Celsius. I think it is getting a older data. Okay, that is all fine. So it is giving a wrong information. You can run it again and see. The point I am trying to make it here is that it is actually pulling the data, and I am thinking it is getting the data from a different search result. So that is why the issue is coming. You can actually try to experiment with that. You can also experiment with the script also. Let us go back to the presentation. And so that is the point I wanted to share with you guys. So I hope that you guys will be able to use this notebook, Jupyter Notebook, as well as the script very helpfully and usefully. Here the link is wrong, but I will be sharing you the correct link in the description. So, and also again, the code will download 4.5 GB of model to your local environment. Keep that in mind when you're executing the code. just blindly, if you execute and suddenly you see, okay, your space is missing, or if your bandwidth is gone, then it's because of the model has got downloaded. So keep that in mind. And yeah, thanks for watching again. Do practice. That is very important, and share this information with others, and also subscribe to my channel. So further updates regarding Langchain as well as various other related libraries to large language models, to Python, and to big data will be shared with you guys. So till the next video, with 4 words, I take the leave. Practice, 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 practice.